Welcome back to the Engineerable channel. So I wanted a smart switch to be able to turn this compressor on and off automatically and remotely. So like at night and over the weekends it would shut down, but also be able to turn it off remotely for any reason, like if we're on vacation, and I'll be able to turn it on remotely or keep it on if we're running some stuff in the pressure pots that needs to stay pressurized overnight. This is a 115 volt AC compressor, works off a regular 15 amp outlet. However, it's a 1.8 horsepower compressor. So most of the plug-in, smart home, smart things, Zigbee or Z-Wave type 115 volt AC relays only work up to 15 amps because they're all like these plug-in styles and they expect people to have 15 amp outlets only. And not only that, but they usually don't have the horsepower rating for this. And this thing will blow a 15 amp circuit oftentimes when it's running, especially if anything else is on that circuit. So I wanted a stronger switch. So the solution I found is this 40 amp switch that's designed to control either 220 volt or 115 volt devices up to 40 amps. 40 amp single phase resistive load, 20 amp ballast load, 1 horsepower at 120 volts AC, 2 horsepower at 240 volts AC. You know, this thing says 1.8 horsepower. It's more than the rating of this. Now I found other large switches like this that could switch up to 40 amps, but they didn't have the physical switch on the front of the device to be able to control it from the location of the device. So you can switch it on and off from that location without having to do it remotely through the app. So that's one thing that was important to me about this switch. It also has a selectable on and off operation for Z-Wave, so it could just be a local switch if you want it to be. You can turn off the Z-Wave functionality. So let's take a look at what's in the box. So we got the manual, the antenna, and some mounting screws. You can see the little wire whip of the antenna sticking out here. So this is the rubber protective cover that goes over that. And that's it in the box. Now this is not a small device. This is a big enclosure. And it's actually good. There's lots of room for routing wires in here. There are several different ways that the power can be connected and monitored to this. So you can do 240 volts AC single load energy monitored, 120 volts AC single load energy monitored, 120 volts AC dual load, load 1 monitored, and 120 volts AC dual load, total of both loads monitored. I am unclear as to whether if you have a dual load, if you can switch each load independently. I'll have to do a little bit more research about that, but my impression is that you can only switch both loads simultaneously. You can't do it independently. Most likely I'm going to use this configuration, 120 volts AC, single load energy monitored. So I'm just going to have one load, which is the compressor and the associated accessories that go with it, like the air dryer, the fan, and the automated drain. I now have the Enbrighten smart switch hooked up to the whole electrical system related around the compressed air that I have here. So the power comes into the smart switch, it goes out into this power distribution block where everything is plugged in. So we have the compressors plugged in here. It's the KOBALT Quiet Tech oil-free compressor, which I have some other videos about how to replace the piston cups in the heads when they wear out, because the stock ones wear out pretty fast. So far these replacement ones have lasted a lot longer than the stock ones. Then another connection goes down to the automatic water drain, so that drains water into this bucket. And another connector goes to this fan up here that I've put here to help keep the compressor heads cool and extend the life of the compressor. And then the last plug goes to this Schultz air dryer. This does a great job of drying the compressed air for everything that I need in the shop. Let's take a look at the insides of the smart switch. So I've wired the smart switch up the same way that it shows how to do the 120 volts AC single load energy monitored setup. So the power in comes in on line 1 and line 2. 1 is the neutral, 2 is a line voltage. And then 3 and 4 are the power out to the load. So 3 is the neutral, 4 is the line voltage out to the load. And then the grounds get connected together at the ground connection point in the back of the box. Everything came together smoothly. The only thing I needed was this 3/4 inch clamp connector. You could also use a 1/2 inch, but in this case a 3/4 inch allowed me to pass 2 wires together and clamp them securely in there. These knockouts were pretty tough to get out. I had to hit pretty hard with a hammer. I was worried about bending the surrounding sheet metal, but it was okay. Just bent the surrounding sheet metal slightly. And then once I popped out the center, I had to pick out the remainder with some pliers. It did not pop out as easy as other electrical boxes that I've used. Since I'm doing an indoor installation out of the weather, it's okay to use this unsealed clamp. But if you were doing an outdoor installation, you probably want a weather sealing clamp. The enclosure does have a gasket on the door that goes all the way around. It leaves a small gap at the bottom, and that's for any water or moisture to drain out. You do not want a fully sealed enclosure, even for outdoors, that doesn't have some kind of drain in the bottom, because condensation, water, etc. could build up in there, and then it will just, like, if it can't drain out, it'll just rise up. So you need to be able to drain out. And you also need to check any drain holes for bugs filling up the gaps and preventing moisture from draining out. The enclosure has 3 attachment points. It's got one hanging tab back here that has a keyhole slot, and then it has 2 screw holes in the back that are already punched out for you. It has 2 status indicator lights. These are kind of confusing because one of them's red and the other one's green, and usually red means something is wrong. However, in this case, red light means that the smart switch is powered on, and then this green light indicates that the connected device is turned on. So if I were to push this button right here, it would turn it off and then back on. And this is the button that gets pressed by the button on the outside of the box. So here you can see off and then back on. Now that same button is also used during the programming stage, where you're supposed to push the button in order to connect it to your smart home hub. I had a little bit of difficulty with this. I didn't know if it was a single push or a press and hold. I finally got it to work. It took a few minutes. It wasn't clear in the manual whether you just push it once or press to hold, because pushing it once just turns everything on and off. So I think it was a press and hold in order to get it to connect to the smart home hub, but there was no like indicator lights flashing or anything during that process. So they could make that more clear. This is the main power switch here. If you turn it to center, it turns everything off. It still shows that it's powered, but now this button no longer works. So if you push this button up to the 1- position, and then it's manually controlled, so it can no longer connect to the smart home hub, and you cannot control it from this front button either. So it's just on or off. If you push this switch down to the 2- position, this is the position at which it's controlled by the smart home hub, or it's controlled by this front button. Now it doesn't need to actually be connected to the smart home hub in order for this button to work. This button will work regardless if it's connected or not. So if I push it, turns on. If I push it, turns off. Now I use the SmartThings app and a SmartThings hub, and it connected. I just scanned the QR code up here, and then I was eventually able to connect to it. Like I said, I had to push this button, press and hold a few times to finally get it to connect. It took a few minutes, and once it's connected, it works great. So here you'll see right now it's off. If I push it on my phone, it turns on, back off, okay, on. The watt meter will demonstrate the watt meter too right now, so it's showing 30 watts. I have to refresh this for it to update. So 157, about 160 watts. That's the air dryer running and the fan running. So that's energy consumption there. I'm going to turn the compressor on now, and you'll see the energy consumption go up. So now with the compressor on, you can see if I refresh it, you're going to see 1.4 kilowatts. So the compressor is pulling about 1.4 kilowatts. If we click on this graph, you can see the amount of power that's drawn throughout the day. Then if you look at the energy consumption tab and click on the graph over here, you can see your hourly and daily energy consumption. So you can actually see like when you're using the most during the day and how much energy is being used over time. For the purpose of this air compressor, I mean, I don't really care. We're going to have to run it. But if you were monitoring something like a pool pump motor and you were interested to see how much energy it's using and if you can save any money, then that'd be a useful feature there. Where this power meter does come in really useful for this setup is to monitor whether it's running too long and shut it down. For example, like if a hose bursts or something is leaking air and the compressor is just running and running and running and we're not here paying attention to it, then the compressor will just continue running. It won't stop, it won't shut down. And so you can set up a routine, and here I already have a routine set up, and I'll show later how to set this up. And this one I've called Air Compressor Emergency Shutdown. So I have it set up like this. If the air compressor power meter is equal to or above 700 watts, so that means that even during startup, when there's no air pressure, or if the air pressure has gone down because it's leaking out, then the air compressor actually only pulls about 800, 850 watts during that time. So here, anything above 700 watts, which means the air compressor is turned on for 30 minutes, then it's going to turn it off. And I've actually tested this, but I tested it for 2 minutes, not 30 minutes, and it actually turned off. It shut the air compressor down, which was great. So in addition to being a remote switch for the air compressor and turning it off during the night when we're not working, it's also useful as a safety for turning it off if there's an air leak and it's running continuously. Under the routines menu, there are already some default routines that I didn't see until I'd already set up a turn off at night and turn on in the morning routine, but you have this routine at the top for power on, example every day at 6 p.m. or a.m., and power off, example weekdays at 10 p.m. And then power on off. So you could do a everyday 6 p.m. to 10 p.m. So I could have just used this power on off, so set it up for every day between 7 a.m. and drag it down to 7 p.m. Have it Monday, Tuesday, Wednesday, Thursday, Friday, and then save that. And the problem is it's going to conflict with my other routines that are there, so I can turn it off right now. But this is the easiest way to add a daily turn on, turn off routine. It's also possible to turn the air compressor on and off just from the main menu by hitting this button right here. And turned on. So overall, I'm very happy with this smart switch to run the compressor and all the accessories. And in fact, I didn't even know when I bought it that it would have the ability to monitor the energy being used by the compressor and be able to shut down the compressor when it's running too long if there's an air leak. So that's a great feature. So if I have any problems with the smart switch in the future, I'm going to report back on it. And make sure you stay tuned for my other videos.